Hey there, Jack Delora here. In this video, we're going to take a look at building this particle-based effect in TouchDesigner and specifically triggering this effect via the monome norns device. We're going to be using a modified version of the awake script, which is one of the kind of default scripts that comes with the norns. We're going to add some OSC functionality to that to send some messages over to TouchDesigner via the network, and then we're going to build this particle system which takes that information, including the note number, and then generates particles, including their position, color, and velocity based on that information. We're going to start this project assuming that you've already set up your norns device. And importantly, that'll mean that you have connected it to your local network and can access it via a web browser. So we're going to head to norns.local in a web browser that is on a device also connected to the same network as the norns, which will bring us to the maiden interface where we can work on things like installing scripts and editing code. Now, depending on how long you have had your norns device and or what sorts of projects you have added or removed, you may or may not have the awake program on your device anymore. So what we're going to do to start is to head over to the project manager. So let's say you don't have it installed. We can head to available, and then you'll head to the community section. You'll probably want to refresh all first just to get the latest updates. And then once you come down here past all of the A's to the end, we have awake, time changes, and you want to go ahead and click install for that. Once you've installed awake, we can head back to the file viewer, and we're going to head to the code section here, which lists all of the different projects that are currently loaded up on my norns device. Then I'm going to head to the awake folder. You'll see then that we've got our Lua script here, the awake.lua file, and this contains all of the code for the front end of this project. Since we're going to be modifying this code, it might actually make more sense to duplicate this awake.lua file so that we have a sort of untouched base version to reference if we accidentally delete or change something that breaks our script. So I'm going to go ahead and hit duplicate up here in the menu bar, and then I'll have a second awake1.lua file. I'm then going to rename that to be, instead of awake1, I'll say awake plus OSC.lua. And that will tell me that this is my special version of this project that will output OSC based on the sequencer playback. One of the first things that we need to know to set up our OSC functionality is the IP address of the machine that'll be running TouchDesigner. An easy way to find this out, although of course there are many ways of doing this, is actually via TouchDesigner itself. So I'm just going to flip over to TouchDesigner, which I've got open already. And then here I've added an OSC in DAT. So to do that, we can just hit the tab key on the keyboard, which will bring up the op create dialog, head to the DAT page, which is all of our data operators. And then we've got here in the second column, the OSC in DAT. Now we're going to use this DAT later on to receive messages from the norns device and then further process that. But for now, we're going to use a handy little function that we can find over here in the parameter window. So if we go here to the local address parameter, this is a text box where we can add in the address of our machine to help filter out different messages that are coming in. If we click on the little rightward facing arrow, that will bring this drop down up that contains a couple of different IP addresses, which are all associated with this machine. So for me, the top one here is the one that I'm going to use. The other ones here have to do with my VPN that I'm running through and some NDI stuff that I've set up in the background. But the one that I'm looking for is this 192.168.0.188 IP address for my local network. So now that we've noted our IP address of our machine, let's head for a moment to the documentation. In the API for the norns device, we've got this section here about OSC. We're going to be specifically using the OSC.send message today, and we're not going to worry about the other ones. We'll notice here that we need in this send function a destination. Now this is going to be formatted as a table which contains the host and the port that will be sending this message to. So what does that actually look like in practice? Thankfully, the norns documentation includes a variety of different studies, and one of these actually covers working with OSC. So this is study number 5, and specifically, this is one called Streams, which has a subsection called Numbers Through Air, which is about OSC. So if we scroll down through this example, we'll see here that we have an example of what this destination would look like in the code in our maiden interface. So here's our destination, which we've set up as a table. And we've got here the IP address, which is a string because, if we provided this set of digits with all of these periods in between, the norns would not really know what to do with it. And then to the right of that, we've got the port, which is just an integer value. So we're going to set up in our code something that looks just like this, and then we'll be able to use that within our OSC.send function later on in the code. So what I'm going to do here is to scroll down from the top of this awake code. We've got a bunch of different variables that we're setting up at the top before we start to get into the function definitions. Here's where I might add in my variable for the IP address. It's kind of up to you as to where you want to place this. There's better ways of organization potentially to keep your sort of communications stuff together. So I might think about placing it, around this section dealing with connecting to the grid or the arc, or we've got some options here that deal with things like the outputs. So yeah, I'll put it, I guess, after this line about the arc.connect. So I'm going to call this td_destination, because that's my TouchDesigner destination address that I'm going to be setting up. And then I'm going to need some curly braces here to set up this table of values. And like we saw in the example, we need some double quotes here to define this IP address as a string. So remember, for me, that was 192.168.0.188. And then to follow the example that we saw here on the monome documentation, I'm going to use this same port, which is 10,101. Now the port really could be set to whatever you want. We just will set this up on the receiving end of TouchDesigner to whatever port we define in the code here, so that those two things can talk to one another. But that seems like a good number, so I'm going to go with that. So I'm going to hit comma and then 10101 for the port. As I've modified my code, I'm going to go ahead and hit the save icon in the upper right just to make sure that I don't lose those changes. Now that we've got our code saved, let's go ahead and scroll down to a section which deals with the sequencer. So we've got this function here called step, which is what actually defines what happens when we take a step through the different steps or notes within the sequencer. So if we get to this sort of middle section here, after we make it through a bunch of different if statements, we have several if statements here for dealing with a couple of different situations where either we're using an internal engine to provide the sound output from the device, if we're instead sending some information out to a Crow device, or if we're sending out MIDI information instead. So basically, this is the section where we are dealing with, regardless of what device or how we are generating sound, triggering and changing the sound based on the current step in the sequence. So what I can do here is to tuck this OSC send message right after this initial if statement that takes us into this branch of the code. So that regardless of what kind of device we're using for the generation of sound or signal, we will trigger an OSC message with that note information. So I'm going to add in a new line here. And this is going to be, if we want to add a comment, our OSC note value out or send. Right, so now what we can do is to call the built-in OSC library, which remember is a part of that API we looked at earlier, and we want to use the .send function. Now, remember we need to supply, first of all, that destination, the area or the device, which is the IP address and the port that we want to send this message to. And we stored that in td_dest for destination. After that, we need to supply a path to send this message to. So if we head back to the documentation for a second, you can see here, this is going to always have a /, and this is going to be a string, so we're going to set this up in double quotes. So I'm going to head back here, and since this is a note value, a MIDI note number specifically that we're going to be sending in this case, I'm going to, of course, add my double quotes, /, and then I will type in note, all lowercase. You're free to use, note number or whatever makes sense to you, but for me this works, especially because this is the only OSC message that we're going to be sending for this example. Next up, we're going to be supplying the data, or in the quote-unquote official terminology, the arguments that we're going to be sending along with this message. So this is going to be the actual note number in this case that we're sending to TouchDesigner. If we head to the documentation study number 5 specifically, what we'll learn is that after the path, we're always going to have a table containing the data, meaning that even if we want to send just a single value, as we will in this case, it still has to be formatted inside of a table. So that means in plain terms, we're going to be using curly braces around our value. So I'll add a comma in after the note path, and then here I'm going to add in the curly braces to set up a table. And what we're going to use here, which we can look down to the section below that will output these types of information, is that we can access something called the note_number, which is going to give us the MIDI note value of the current step in our sequence. We also have the option, if you want to use the frequency value, which is going to give you the value of the sound in hertz instead. But for this particular example, we're going to be using the note number just to keep things a little bit more straightforward. So I'm going to type in note_num within those curly brackets, and we can then hit save to save our code. So you can see in the lower right of the screen, we're receiving a stream from the norns, and this is the default sequence that will load up with the awake program. From here, we can actually head over to TouchDesigner and see whether or not we're actually getting any of the OSC messages coming in. So assuming that you still have the OSC in device in your TouchDesigner network, we're going to go ahead and set it up to actually receive the messages from our norns. At the moment, it's not receiving anything because it's looking at the wrong port. Right now it's set to the default of 7000, but you'll remember that we set up in our code to send our messages to 10101. If I hit enter and give it a second, we should now see note values coming in, and those are coming directly from the norns itself, as we can see in the lower right of the screen. If you're on Windows and running into issues receiving these OSC messages, take a look at the Windows firewall, as it is notorious for causing issues whether you're sending or receiving OSC messages. I'll post a link in the description below to a page on the TouchDesigner wiki with more info about how to set that up. So I've paused the playback of the norns for now so that we can set up the network to be ready for us to then write a little bit of Python code and modify some parameters of a couple of different operators. We're going to be setting up a fairly standard set of operators to create a 3D scene, some geometry within that scene, and then a rendering pipeline where we take that geometry and we render it to a 2D texture and be able to use a camera to view it from different angles. So to start, we're going to be creating the geometry itself. And since we're going to be working with particles specifically, all we need to supply to start is a single point. So to do that, we're going to use the add SOP. And the add SOP has the ability to, via this add points switch, to add a single point, which in this case is located, although we can't really see it, right at the center of all three axes. So within this operator, all we've done is turn on this add point switch, and now we're going to move on to our next operator. A quick tip if you're new to TouchDesigner is that you can click, right click that is, on the output of any operator, which will automatically bring up the opcreate dialog. And then what we can do from there is to add our next operator, which is going to be a convert SOP. And just like that, it will automatically create a connection between those two operators. So the convert SOP, this one is kind of interesting in that we can use it to convert between different types of geometry. And in our case today, we're going to use this to take our simple point and turn it into a particle. So we've got here this convert to parameter, and you'll see here that we then have, if we go all the way to the bottom, particles per point, which will give us some attributes associated with particles and also allow us to choose to render the particle as a point sprite rather than a line. So we're going to be setting here just this convert to particles per point, and then set the particle type here to render as point sprites. To allow us to experiment further with this project later on, I'm going to add a null after the convert SOP by hitting Alt-N on the keyboard or Option-N on the Mac. Here, we've got our final kind of step of this SOP network, and I'm going to right-click on the output of the null, head to the comp page, and we're going to connect this to a geometry comp. So the geometry comp is the kind of translator of sorts between this world of our abstract 3D geometry and then taking that and doing things like rendering it to a texture. So we need to take any of the geometry that we want to render and connect it to a geo before we can actually do anything with it in terms of outputting it or texturing it or things like that. So the geo is now connected, and I want to stress here that I right-clicked on the output of the null one to create this geo, which again brings up the opcreate dialog and automatically makes the connection between these two operators. If you had simply added a geo comp to the network separately, you'll notice that it doesn't have inputs or outputs on the left and right. So when we do that, right-clicking from the output of a SOP operator, or a surface operator that is, it's going to automatically create those ins and outs for us and use whatever geometry is contained within this operator within the geo comp. So that's a handy little shortcut, which you'll definitely use elsewhere. So let's continue by rendering this, at this point, single point in our geo comp to a 2D texture, just so that we can have that ready to go when we then work with our particle system. So I'm going to start by opening up the opcreate dialog by hitting the tab key or double clicking in the network editor. I'm going to grab the camera comp. I'm going to place that over to the right, and this is going to be the camera for our scene. To the left of the camera, I'm going to add in a material. So I'm going to once again open up the opcreate dialog, head to the matte page for the different materials that we have available, and then I'm going to add in the point sprite material. To assign this to the geometry, I'm going to click and drag it onto the geo comp, which is going to bring up this little dialog. I'll click then the parameter material. What that's done is on the render page of the geo comp over in the parameter window, we can see that it is now referencing the point sprite material. So from there, I can add in a texture, which we'll use as the color map for this point sprite. And actually, I think it'd be easier for us to see if I first render this to a texture. So I'm going to grab the render top. This is the other important aspect of our rendering setup. We need to have a render top to actually take that and render it to a two-dimensional texture. Now, if you were to zoom in really close, you might see that at the very center of this texture, we have one small dot, which is corresponding to the single point that we are generating at this moment. In the point sprite material, we can actually come in here and set the scale of this point so that we can actually see it within our output. And thus, when we have additional particles, we'll be able to see those as well. So I'm going to set the constant point scale here to 20. And you'll see then that that has now given us a square at the center, which is a little bit more visible. Now, later on, we're going to modify the camera positioning a little bit, so the scale of that will be adjusted depending on the distance of the camera from this object in space. But for now, we can at least see something being output in the render. Now let's take a step back to the color map. You'll notice that this is a square, and for the kind of aesthetic that I'm going for in this example, I'd like it to be a circle instead. And so I can use a circle texture on the top page, a circle top, and apply that as a color map for this point sprite material to change this square into a circle. So once I've added the circle top to the network, I'll just simply drag it onto the point sprite material. You'll see that the color map parameter over on the right now shows circle 1, which is referencing that operator. And then if I zoom in on the render, we see that we have a circle at the center rather than a square. Because we've got transparency in this texture, I'm also going to come to the common page. I'm going to turn on the blending transparency option so that we are correctly dealing with that when we have things that are overlapping one another. I'm also going to turn on the discard pixels based on alpha and set that to 0.1, just again so that we're kind of prepping ourselves for having the potential of different particles overlapping one another. So we've had a ton of talk about particles, but we have yet to see any of that in action. So let's move on to actually adding in the particle system to this project. So I'm going to take this add SOP and reuse it, because once again, we're going to need to supply an operator with a single point to then use as the sort of source, and then we're going to use our code actually to add in additional particles to this particle system. So we've got here with our add SOP a single point being generated, and then I'm going to use another operator called the point SOP in this case to add an additional attribute to the point that we've added with the add SOP. So the point SOP allows us to modify all kinds of different attributes that are related to this point, including things like the position, the normals associated with the point, etc. And one of those is here we have the option to assign a color to that point. So in this case, I'm going to set this from this keep color setting to add color. And I'm going to leave all of these settings alone. Now what's happened here is if we middle mouse click on this first add SOP, we've got 1 point, and if we come down here to the attributes, we only have the normal set for this attribute. If we then middle mouse click on the point SOP, we now have 2 point attributes added, a normal and a color. And that means that later on when we're working with our code, which is again processing those OSC messages, we now will have a color attribute for every single particle that we're generating that we can then modify with that code. So with that, we can actually connect this directly to a particle SOP. So the particle SOP is how we're going to generate our particle system. And right now, we only have a single point. So again, not a whole lot happening here. That's okay. We're going to add in our code to parse and to generate some particles. However, while we're here, I want to make some quick adjustments to the particle SOP. These are going to be sort of in preparation for generating a whole bunch of particles with our OSC messages. So I'm going to come to the particles page, where I will then set the birth value here to 0. So by default, the particle SOP is going to just start generating particles based on whatever geometry is connected to this first input. And what we want in this case is for our OSC messages to cause the particles to be generated instead of them just automatically being added into the system. The next thing that I want to do is to set the life expectancy to a lower value. So right now we have a life expectancy of 3. I'm going to set this to 1 so that the particles are not on screen for quite as long, and it'll give us more definition between the different notes of our sequencer. So with that, I'm going to add in a null to the end. This is going to be used to provide translation values for the different instances of this point that we generate. So I'm going to call this null space t, just to kind of specify what that's for. And I will go ahead and assign that to this geocomp right now. So within the geocomp, we have a page called instance, and then we've got instance 2, instance 3. This lets us use the instancing functionality, which I talked about briefly before, which allows us to create copies of this piece of geometry based on a variety of different things, including the point positions of the points contained within this SOP. So what I'm going to do is turn this instancing switch on. We're going to use this operator for our translate op parameter. I'm going to drag that onto the translate op. And then I will pull in the P0, P1, and P2 channels, which will give us these are, again, attributes. These are the point positions for each one of those points. So P0 means it's going to give us the X value for that particular point. Again, Y value for P1, and P2 is going to give us the Z value. So not a whole lot has changed. It looks exactly the same because, again, we're only generating a single point. So what this is all pointing back to is that we need to now start processing our OSC messages. So I've gone ahead and started up the norns sequencer again, and I've changed up the sequence in awake so that it's a little bit different than the default one and gives us a little bit different variety of notes. From here, we're going to open up the OSC in one callbacks code in an external code editor. If this is your first time working with TouchDesigner, you can set this up via the preferences, which you can access via the edit dialog here, edit preferences. On the DATS page, we have the text editor option, which on Windows, you're going to have to point to the actual exe of the program that you use to edit code. If you're on Mac, you can just point to the program in the applications folder. Either way, once you have set up a program here, you can simply click on the OSC in one underscore callbacks and then hit Control E if you're on Windows or Command E if you're on Mac. It's going to open up that code directly in that program, and ideally have it set up to interpret the code in the correct format, which is Python in TouchDesigner. In a pinch, you can always right-click on the operator itself and hit View, which will open up an external viewer window, which does have the same sort of color-coded text formatting, making things a little bit easier, but doesn't have the kind of autocomplete stuff that a more advanced code editor might have available. Regardless of what software you use, we're going to have to make some changes to this code for anything to happen. So you'll see here that we have this onReceive OSC function, which has a bunch of different arguments. And up here, we can see a little bit of further description about what those things do and what they provide to us. And the ones that we're going to be focusing on today are specifically the address and the arguments that are provided via this function. So we're going to use the address to parse through the OSC that's coming in and pull out the specific messages that we want to be able to see. So to do this, we're going to use an if statement. So if the address equals, and then we want to set up single quotes and then /note, then within our if statement, let's go ahead and print the args. So remember, we're using the address to parse out which particular message we want to take and then utilize in our project, but the message contents are not within the address portion, they're within the arguments portion. So here we've got arguments, which we know is going to be a table. And because we know that there's only a single value in this table, I can simply access the first index of that table of information by adding a set of brackets and then entering a value of 0. Here I can then hit Control S to save my code and head back to TouchDesigner. To be able to see that printout, we can open up the text port by hitting Alt-T on Windows or Option-T on Mac. And you'll see here that I've got all of those numeric values coming in from that OSC message showing me the current note value. So I can hit clear again and watch that fill up with the different note values being provided by the norns. So we are successfully receiving and now parsing that data that's coming in. Let's start to take that and then send it to a couple of different locations. So back in the code, we're going to do a couple of things. We're going to import a few different libraries, which will be accessible with the TouchDesigner installation of Python. That's first going to be the NumPy library to do a little bit of processing and changing the range of the values that we're receiving via the input. And another one is called color sys. So color sys. This is going to give us some useful functions for converting between HSV, that's hue, saturation, and value, to RGB values, which are the kind of default way that we're dealing with color in TouchDesigner. So back to the code within the onReceive OSC function. We're going to get rid of this print message for now because we know that that is working. And I'm going to use right away the NumPy library to take the note number that's coming in and normalize it to a more useful range for our work in TouchDesigner. So I'm going to set this to a variable name of note. So note is going to be equal to numpy.intrp for interpolate. Then we're going to need to provide some things to this interpolate function, including, first of all, the value or the variable that we want to perform the interpolation on. This is going to be the args0 value that we looked at before, which again is our current note value from our sequencer on the norns. Then we're going to need to provide a list which is defining the input range of those values that we want to take into account. So I looked at the output of the awake script, at least with the default settings, and that gave me note values between the range of 60 and 86. In our case, I didn't end up using or hearing notes in the 80 to 86 range quite as frequently, again, with the particular sequence that I'm working with. So I'm going to use a range of 60 to 80 in my case, but you're free to experiment with this depending on the sequence that you're using. Then we need an output range. And for this, I ended up going with -1 to 1 so that we can work outside of, say, the positive axis in 3D space, whether that is in the Y, Z, or the X direction. After that, we're going to start generating some particles. So first of all, I'm going to set up a variable called particles because this function actually is going to return some information to us. We're going to access our particle operator by typing in op, open and close parentheses, single quotes, and then this is particle 1. So that's our particle 1 SOP that we're accessing. That has a function that we can access called .create particles, which is going to generate a bunch of particles for us. And then within our parentheses, we can supply the number of particles that we want to generate. So I'm going to type in a value here of 10. So once we generate the particles with this function, it's going to return a list containing the information relating to those particles, which has been stored into this particles variable. Now let's set up a simple for loop to iterate through the particles in this list and make some changes to them. So I'm going to type in for index in range, and then len for length. Again, need to set a parentheses there. And then I'm going to access the particles list that we just set up and stored our particle information into, and add a colon to the end. So this is saying for index in the range of the length of this particles list, which will be the number of particles that we've generated. So in the range, starting at 0 and increasing up to the length of this particles list, we're going to run the code contained within this for loop. So if we then hit enter, we can start writing the code within that loop. So what I'm going to do here is to access each particle contained within that list and store that into a variable called p. So this is p as in point or particle. We're going to use that kind of interchangeably at the moment. That's going to be set to p equals particles because that's, again, the list where we store all that info. And then to access the current point or particle, we are going to supply the index value coming from our for loop to this particles list, again, to get the information relating to that point at the current point in our for loop. So at this moment, we have now given ourselves the ability to make changes to the attributes of the current point that we have stored into this variable p inside of our for loop. And again, if you're not familiar with this, maybe it's your first time working in TouchDesigner, let's take a look at the derivative wiki for a moment. So every point in TouchDesigner has attributes associated with it, which we can see here on the attribute page in the derivative docs. And if we scroll down, we can see here we've got a list of all the different attributes that can be associated with a point. So as we can see here, the uppercase P attribute is related to the point position and has a list of 3 floating point values to define the XYZ position of that point. We also have a normal, which we can set up here. And then as we looked at earlier, we can set up a color value with this CD attribute. Now, important for the situation where we're working with particle systems, we can also have a velocity value associated with that particular point, and we can set this as it's an attribute of the point. So we're going to use the code here to modify a couple of things. We're going to set up the point position, again, by accessing and modifying this attribute. We're going to set up the color by accessing the CD attribute, and then we're also going to set up the velocity of that particular particle via the V attribute. Let's head back to the code and look at this in practice. So if we want to modify the position of the particular point that we're currently acting upon, we will first type in P, because that's the lowercase p, that is. That's the current point that we've stored into this variable. And then if we want to access the attribute for the position, we'll type a period after that, and then add an uppercase P to modify the position attribute. We're going to set that equal to, again, we need a list containing 3 different floating point values. And for this, I'm going to use the note values specifically. So they're going to be used for the X, the Y, and the Z positioning of the particle. Then we are going to set up the velocity of that particular point or particle. So P.V is going to give us the velocity attribute of that particular point. We're going to set that equal to, again, a list, which is going to contain 3 different floating point values. Now, to give ourselves a little bit of variety in terms of the velocity, we're going to use some built-in functions to TouchDesigner to add a little bit of randomness. I found that this gave it a little bit more variety to the output rather than just sort of seeing the same sorts of movement patterns over time. So TouchDesigner has a function called rand for generating a random value between 0 and 1, and we access this via the TDU library. So tdu.rand parentheses, and then we need to supply a seed value, which is going to be abs time with a capital T dot seconds. This is a counter that counts up from the moment you open TouchDesigner. Basically, when we access this, it's going to give us a different value every time, and thus is great for things like a seed. I'm then going to subtract 0.5 from that so that I can get a value that falls within the range of negative 0.5 to positive 0.5, and thus, gives us, again, something that's more balanced around the center of all of the axes that are meeting, instead of kind of focusing on, let's say, the positive range of 0 to 1 in our X, Y, and Z axes. So this is just the component for the X velocity value. I'm going to add a comma and do the same for the Y velocity, except that I'm going to modify this portion within the tdu.rand function. I'm going to add 1 to the abs time.seconds expression here so that we have a slightly different seed for the Y velocity. So they're not all going to be the same. Likewise, I'm going to copy that again and then paste it so that for the Z velocity, I'm going to modify it so that we add 2 to abs time.seconds, again, so that we get a slightly different velocity value in the Z direction. Finally, we're going to be assigning color values to each one of these particles. And for that, we're going to set up a variable, actually, first, to do some modification of our color using the HSV to RGB function coming from our ColorSys library. This will allow us to work with hue values, which are in the range of 0 to 1, but really in terms of degrees, 0 to 360, and give us sort of an easier way of dealing with color than if we just specified RGB values directly. So I'm going to type in P color as my variable, as in particle color. Then I'm going to use the ColorSys library, and I'm going to access the HSV_to_RGB function. and then add my parentheses there. Here I'm going to supply my n value, which again is coming, or the note value, which is again the note number that's coming in from OSC. Then I'm going to set the S or saturation value to 0.85, so we have a little bit of desaturation going on. And then I'm going to set the value to 1. Finally, I can set the color attribute of the particular particle that we're looking at by typing in p dot capital C lowercase d, and then setting that equal to p color. This is actually it for our code. So I can now hit Control S or Command S if you're on Mac and head back to my TouchDesigner instance. And what I should see is that we've got some stuff going on in our Particle SOP. Now, we can't really see a whole lot here in terms of functionality because the points that are being generated, the particles, are very small. But if we come up here to the geocomp, we can see that we've got some particles now being generated, which are starting to move around on screen. Now we have a couple of things that we need to do to modify this because at the moment things are, not really looking like they did at the intro, and that is due to a number of different things. But one of the first things we can do at least is to set up the color of the particles that we're generating. So the color is, again, added in to the particles that we're generating as an attribute. And so that means that it will be accessible via this null underscore t operator that we set up earlier, as we can see by the 5-point attributes that are available. So we've got velocity, we have the CD here at the end for the color, and of course the point position. So let's head back to the geo where we can take advantage of that color that we've set up, and we'll head to the instance 2 page, which is where we can deal with things like color. Here I'm going to supply the null underscore t operator again, and then I'll pull in for the R, G, and B channels, the CD0, CD1, and CD2 values, which again are corresponding to R, G, and B color values. And then we'll see over here that we have now some color appearing in our output. But again, it still looks a little bit different than what we saw initially. So what I did to kind of add a little bit more interest to this particle system was to, first of all, set up a little bit of turbulence on the forces page. So simply by increasing the turbulence values here to 1, which I'm going to do via the value ladder. So I'm going to middle mouse click on turbulence, move while still holding the middle mouse button down. I'm going to move my cursor up to 1 and then move to the right slightly. I've increased all those values to 1. And now that we're adding turbulence to the particles within the scene, you can see that the movement is a little bit different. They're not simply just kind of moving in straight lines. They're being pulled around a little bit in space. But that's not quite it for our particle system there either. Another cool thing that we can do is to add in a surface attractor, which is going to be a piece of geometry that the particles will be attracted to, and thus will start to change their positioning a little bit because they'll be pulled towards that object. So for this, I'm going to use a very simple sphere SOP. So I'm going to add that in to my project. And then I'm going to set the primitive type here to polygon, which will kind of simplify and reduce the number of points. I'm going to reduce the radius value here to 0.8 for X, Y, and Z. Then I'm going to connect this to the third input, or actually the fourth input, which is called input 3 surface attractors. Now let's take a look at the output. We can see right away we've got some really different stuff happening. Instead of all of the 10 points that we're generating simply kind of following the same trajectory on top of one another, they are now spreading out and acting a little bit differently, which is great because it adds, again, a little bit more interest to what's going on in the scene. Now, again, this still doesn't look quite like what we had going on in the intro. It's not quite as interesting. So let's continue on. We're going to do some post-processing here to make this a little bit more interesting. First of all, I'm going to head to the comment page. I'm going to set the output resolution of this render to be 1024 by 1024. Then I'm going to set the pixel format here to 16-bit fixed because we're going to be using something called feedback in a moment. And when we're working with the default 8-bit fixed pixel format, we're going to end up with a little bit of artifacts as the feedback sort of trails out to transparency once again. Another thing that we need to do here is to change the camera view. So the camera is a little bit different than what I had set up initially. It's a little bit farther away. And so what we're going to do here is to head to the camera itself. We're going to set the view here from the perspective projection mode to orthographic. So by simply changing the projection mode here, we now have everything being displayed on a sort of flat plane, and we can work on processing this output a little bit to make it look a little bit more interesting. So I'm going to open up the palette in this case by hitting Control B or Command B on Mac. I'm going to head to the image filters section, and then we've got a bunch of different tools pre-built that are very useful for doing some post-processing. I'm going to use the option here called feedback, and I'm going to add that into my project. Then I can close the palette, and here I can connect the output of the render to the input of the feedback comp. And I'm going to turn up the opacity value here to 0.95, which will give us a little bit longer of a trail, but they'll still kind of fade out. And once you've done that, we have something that is very similar to what we had at the beginning of the video. You can continue working with your post-processing here, doing things like compositing in backgrounds or, say, modifying the color of the output of this effect. But the essentials are complete, and now it's really up to you to continue experimenting. Of course, the particular sequence of notes that you choose is going to really modify how this output functions. And so what I might recommend is that you play around with the code that we had set up earlier, changing things like the minimum and the maximum of that interpolate function that sort of normalizes, quote unquote, the output range of those notes so that you don't run into the situation that we have here where we have some notes that are sort of generating and being cut off in the render. Another thing to think about is that you can always change the camera positioning or the render scale so that we don't lose so much of those lower notes. For just a quick example, if I set this lower bound of the interpolate function to something like 55 and then hit save and then come back to my output, what we'll see is that those previously cut off portions, because we've set our lower bound a little bit lower even, are now appearing fully within view, and thus it looks a little bit better in terms of the overall composition. So I hope this has been a useful first look at working with the norns device, specifically the awake script and TouchDesigner. Hopefully it's really given you a chance to take a moment and consider the possibilities that are now available since the norns device has such easy integration with OSC messaging. Another thing to mention is that, of course, you don't have to have a norns device for this to function. Really anything that can send OSC, including even really another TouchDesigner patch, is fair game to use here. But this can start you thinking about how you can use the norns device or anything really with OSC to communicate with TouchDesigner and generate different effects of your own. So we're going to have a ton more norns focused content here on my channel coming up. I wanted to take this moment to thank you for watching and remind you to hit the like and subscribe buttons along with the little bell icon below so you can keep up with the latest videos and content that I'm posting here on YouTube. If you want to find me on Instagram, my username is the same as it is here, @JackDelora. Make sure to follow me there, where I'll be posting more of my experiments and output from the different videos that I make for YouTube. So with that, I hope you've enjoyed putting this one together. Looking forward to seeing you in the next video. Thanks so much for watching.